Morning, dear students. Today we are going to derive one expression, that is expression for energy of electron. Energy of electron in hydrogen atom. Hydrogen atom by using Rutherford's atomic model. Now we are all familiar with the Rutherford atomic model. By using that model, we are going to derive the expression for energy of a electron in the hydrogen atom. Here why they have choose the hydrogen atom is nothing but the hydrogen has one electron system. If you are considering this as a atom, in center the nucleus is present and only one electron is present in the system. Therefore this system for that purpose they have taken hydrogen atom. It is easy to calculate by taking the hydrogen atom. Okay, now we are going to derive the energy of this electron. Okay, the electron is revolving around the nucleus in a circular orbit. So the radius of the circular orbit, it will be r, small r. Okay, now for this derivation we are going to write the charge on the nucleus. Charge on the nucleus. So you all know that the nucleus is positively charged. Therefore the charge of the nucleus can be written as plus Ze, where Z is the number of protons and E is the charge on the proton. Therefore it will be plus Ze. Okay, therefore you write here plus Ze. So next, the mass of this electron. The mass of electron, let m be the mass of electron. M be the mass of electron and minus E be the charge on electron. Charge on electron. Minus E is the charge on electron. Let R be the radius of circular path. Radius of circular path. So these electrons are revolving around in a circular path around the nucleus like the planets revolving around the sun. So therefore this radius we are taking it as a r. Okay. Now V is the velocity of the electron. Velocity of the electron. Here only the electron is revolving, therefore its velocity will be in this direction. So let V be the velocity. Sometimes it is also called as orbital velocity. Now we are going to write the energy expression. This electron, it will possess two types of energy, that is the sum of the kinetic energy and the potential energy. You know that the energy of the system is the kinetic energy and the potential energy. The kinetic energy is nothing but it is due to the motion of any particles. So if you are moving, you will possess the kinetic energy. If you are in the state of rest, then you will possess the potential energy. These all you are studying in first year. So here what happens, the electron possess the kinetic energy due to the orbital motion. This is called as orbital motion. It is moving in a circular path. So that is kinetic energy due to orbital motion. Due to orbital motion. And the potential energy. Potential energy is due to the presence of charges on this nucleus and the electron. So potential energy is due to presence of charges. Presence of charges on nucleus and electron. Okay. Therefore the total energy, what is the total energy? Total energy is equal to sum of kinetic energy plus potential energy. Okay. The total energy is sum of kinetic energy plus potential energy. Take it as equation number 1. Now we have to calculate this potential energy as well as this kinetic energy and we have to add it, then we are getting the total energy equation. Okay, understood? So now the expression for this potential kinetic energy. Okay, first we are going to calculate the kinetic energy. From Rutherford's model, for stable orbit, orbit. For stable orbit, centripetal force is equal to electrostatic force. Centripetal force is equal to electrostatic force. This is the last postulate. So you can see that. Okay. The electrostatic force is balanced by the centripetal force. Therefore, we are using this Rutherford model. So therefore, it is centripetal force is equal to electrostatic force. So what is the expression for centripetal force? It is mv square divided by r is equal to, what is the expression for electrostatic force? Electrostatic force nothing but it is Coulomb force. F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by it is R square. But what is Q1 and Q2? Here Q1 is equal to the charge on the nucleus, that is plus Ze. Q2 is equal to it is charge on the electron. So that is taking only the magnitude, therefore Q1 Q2 plus Ze to E. Therefore you can write it as 1 divided by 4 pi epsilon naught plus Ze into E divided by the distance, it is R square. It will be like this only. Now here you can cancel 1 R. So 1 R it is cancelled here, cancelled. So you are getting mv square is equal to Ze into E, that is Ze square divided by 4 pi epsilon naught into R. But what is kinetic energy? Kinetic energy is, kinetic energy Ke is equal to half mv square. Now seeing this expression here, half is missing. So what we will do? Multiply 1 by 2 on both sides. So multiply 1 by 2 on both sides. Then you are getting 1 by 2 mv square is equal to here also 1 by 2 into Ze square divided by 4 pi epsilon naught. So this implies that half mv square is nothing but it is kinetic energy. Ke is equal to 4 into 2, it is 8. Therefore Ze square divided by it is 8 pi epsilon naught. So here one R is missing, that is R. So this is the expression for kinetic energy. Take it as equation number 1. Now you have to derive the expression for potential energy. The potential energy is nothing but it is due to the presence of charges on nucleus and the electron. In the second chapter, you will get the definition as the potential energy is equal to, it is electric potential at a distance r due to plus Ze into charge on the electron. You will get like this. Potential is equal to electric potential at a distance r due to charge plus E, that is nucleus, into charge on the electron. So you can write it as this equation. The electric potential energy equation is given by V is equal to, it is 1 divided by 4 pi epsilon naught Q divided by it is R. But here Q is nothing but it is Ze. So you can write it as Pe is equal to, it is 1 divided by 4 pi epsilon naught. Q is nothing but it is plus Ze, that is plus Ze divided by it is R, into the charge on the electron, it is minus E. Therefore you can write it as minus E. Okay. So now multiplying this, you will get potential energy Pe is equal to plus Ze into minus E. You are getting minus Ze square divided by 4 pi epsilon naught into R. This is the expression for potential energy. Potential energy is given by P is equal to minus Ze square divided by it is 4 pi epsilon naught. Take it as equation number 2. Now what you have to do? So you got the two equations. That is equation 1 is total energy is equal to Ke plus potential energy. Equation 2, so make it as equation number 2. Equation 2 is kinetic energy is equal to Z square divided by 8 pi epsilon naught, and this equation as PE is equal to minus Z square divided by 4 pi epsilon naught. Now you have to substitute equation 2 and 3 in equation 1. Therefore equation 1 becomes equation 1 is total energy is equal to kinetic energy plus potential energy. Therefore we will write it as total energy is equal to, what is the expression for kinetic energy? It is ZE square divided by 8 pi epsilon naught R plus, what is potential energy? It is minus Z square divided by 4 pi epsilon naught into R. Okay, so now see here, Z square divided by 4 pi epsilon naught, R is common, take it outside, that is Z square divided by 4 pi epsilon naught, R is common. If you are taking the R is common, this whole term is common, here 8 is there, therefore you are left with 1 by 2. Minus here, all you have taken, therefore it will be minus 1. So that is Z square divided by 4 pi epsilon naught, bracket 1 by 2 minus 1. What is 1 by 2 minus 1? It is minus 1 by 2. Therefore, Z square divided by 4 pi epsilon naught R into minus 1 by 2. So this is minus 1 by 2. So on multiplying this, you are getting the equation as, that is, you can write it here, total energy is equal to, it is, here you can say Z square, that is Z square divided by, it is 4 into 2, it is 8, that is 8 pi epsilon naught into R. Here minus sign is there, so you can take it as minus here. Therefore the total energy can be written as, total energy TE is equal to minus Z square divided by 8 pi epsilon naught R. Okay, this negative sign indicates that the electron is bound to the nucleus. So you saw here, this is the nucleus and the electron, it is fixed around this. So therefore this negative sign indicates that this electron is bound to the nucleus. In order to take out this electron, you must supply some energy. This is the expression for total energy. So here I will write it as total energy is equal to minus ZE square divided by 8 pi epsilon naught R. This is the expression for total energy of electron in the hydrogen atom by using Rutherford atomic model. Okay. Now the merits of Rutherford model. So what is the merit of Rutherford model? Rutherford model explain the large angle alpha scattering. So you are familiar with the alpha scattering experiment. There you can see that it explains the large angle scattering from 0 degree to 90 degree. Back scattering also it is explained. Therefore it is the merit. Then what are the demerits? So you have studied about this in your chemistry classes. Here we are going to study that what are the demerits of atomic model. There are two main demerits. That is, first, it could not explain the stability of the atom. So stability of the atom, it does not explain. How it does not explain the stability? According to this electromagnetic theory, the accelerated charged particle. So you all know accelerated charged particle means nothing but one particle, it is moving with a acceleration. When it is moving with this acceleration, it will liberate energy. If it is liberating energy means its energy goes on decreases. So example, if you are in a running race, if you are running and due to acceleration you will lose your energy. After some time you will fall down. Same here, this electron, it will lose its all energy and its radius goes on decreases. Radius decreases and it will be collide to this nucleus. Here you can see that this electron is revolving and it gain energy, and this energy is liberating. See here, this it is showing. So after releasing energy, the radius is decreasing and it is coming to hit this nucleus and it collapses. Therefore, it does not explain the stability of the atom. Second one, It could not explain the origin of spectral lines.